Starting the 2017 paper 2. We're trying to figure out some of our questions, probably 1 to 6 today, and we'll do the rest of them tomorrow, we're hoping. Okay, so we have our original shape. Here is our original shape. You can see I'm colouring in the corners here just to colour code them for you. So we have a blue corner, a red corner, a green corner, and finally a purple corner. Okay, now we're looking at what's going on. So write A, B, C, and D into appropriate places in the table below. Show which image comes from each from each transformation. Okay, axial symmetry. Well, axial symmetry is like a perfect reflection in an axis. So example is, if it was axial symmetry in the y-axis, it should look something like this. Give me a second. Just want to show you what axial symmetry in the y-axis would look like. So axial symmetry in the y-axis, see the way it's a distance of 1 away? It'd be something like this. Except the colors would change around because see the way it's mirror imaged in the y-axis. But oddly enough, see the way the green is 1 meter away? That means this one would be the green one, which is 1 meter away. And the red one's 4 blocks away from the y-axis. This would mean this one here is the red one. So that would be axial symmetry in the y-axis. However, axial symmetry in the x-axis is completely different, and we can see it down here. That this red block here is 1 away, and that means it would be down here as well. This green one is 1 away, which means it'd be down here. And finally, the blue is 3 away from the x-axis, which means it'll be 3 here. So image B is definitely axial symmetry in the y-axis. That's image B. Okay, central symmetry in 0, 0. Now let's see where central symmetry is. We get our original image, and what I reckon is we're going to end up with this one here like this. If I do that point to that point, this point to this point, this point to this point, and finally this point to this point, we can see that it all converges on central symmetry through 0, 0. Okay, so it's definitely image D. Okay, so image D is central symmetry through the origin. So that's B, that's D. Rotation about 0, 0. What would rotation be? 0, 0 rotation. I wonder if we could imagine like a circle here or something like this. I'm struggling to think about this one myself. Something like that. Now, suppose rotation around, it's got to be image C, because image D is a translation. Let's just do image D first, and I'll try and explain image C in a second. Image D is a translation. So basically, if you take a translation is where you move all points the same direction and the same amount. So you imagine this purple point here goes 3 points to the right, 2 points up. So 3 points to the right, 2 points up. Take the red point, 3 to the right, 2 up leads it here. Take the green point, 3 to the right, 2 up, and finally take the blue point, 3 to the right, 2 up. You can see that image A is definitely translation. So rotation about 0, 0 would have to be C by process of elimination. Now, if I was trying to teach this one, I suppose what I'd have is I'd snapshot this like so. Okay, and I'd try and go back one. I'd snapshot this like so. Okay, and just keep it here beside me. Now I'm going to make a circle centered at 0, 0. And let me show you what I'm trying to do here. So here's my circle at 0, 0. Like so. You can see that it hits all those points around here. So that's my circle. Okay, now I'm going to attach my circle to this shape. Once again, it crosses at that point there. So I'm going to combine the two of these together. And I group them. Now look what happens when I do this rotation. I was finding it hard to visualize the rotation, but now I'm going to see if I can do it like so. Ready? See what happens when you rotate it? It should, oh wait, I'm not getting that perfect. I need this to be perfect. try again here. Basically, it should rotate it into this position here, something like that. You get the visuals of it. So it does rotate, and if I center that again, it rotates directly into position, okay? So it should rotate directly into position. I'll give it one more go. Let's see if I can make it pop up. No, I seem to be rotating off axis there, but you get the gist. It's rotating it into position. Process elimination as well. Okay. Have to draw this into 3 equal line segments. So first of all, I just grab a line and draw it out as long as I can. I get a compass like so. Where is my compass? Alright, pick 3 random lengths. Any length I want, to be honest. Just once it fits in. So here's what we're going to do. Once, twice, and then 3 times. Okay, there you go there. Next thing I'm going to need is a compass, two straight edges, which is this guy here and this guy here. Okay, so what we do first is we link, we draw a line from here to here. Now it's not usually it's not meant to be 90 degrees, okay? So something like that. See that angle there? Now what I have to do is I have to reproduce this angle two more times here, okay? Now the great thing about this question is you can see whether it's right or wrong at the end, because you can measure it up basically. So if I was to say that this was, for argument's sake, I'm just going to turn it into a 12, all right? If this is a 12, it should come out as 4, 8, and 12. It should be cut perfectly into 3 equal slots, okay? Now to make sure I'm going to get this angle absolutely perfect, here's what I have to do. I have to size up my, actually probably better doing it this way instead actually. Sorry, excuse me a moment. I'm just going to level this off for a sec. I'm going to grab this here and I'm going to move this, see this edge here, I'm going to make sure it's parallel to that dotted black line there. So I'm trying to just smooth it in like so. And then I've roughly got it there. Now what I'm going to do next is I'm going to adjust my ruler so that it can slide on my ruler, like so. Now using friction, basically two of those guys have to, you hold, you put your hand here, you hold that in position, and you, oh god, I didn't mean to do that, and you slide it across. So when I slide this across, like so, we're going to get the same, angle as the previous one. So basically they should be corresponding with each other, like so. There you go. So that should be it, done. And if I measure it up, it should be at 4 and 8 respectively. There you go. Very approximately right. Okay, that's that one done. D. The diagram below shows a rectangle ABCD. A, B, and CD are divided into 5 equal parts. Some of the endpoints are joined by line segments shown. Find the percentage of the area of ABCD that is shaded. Show all your work in the workings. Okay, this is going to be interesting. Okay. Is it a rectangle? It's a rectangle, okay. And show the percentage of area that is shaded. So I have to get the shaded part. So what I have here is I can do, alright, it's not so bad actually. So what I'm going to argue here is that I have a rectangle 1, triangle 2, triangle 3, and rectangle 4. Okay, I'm going to, for argument's sake, I can make up numbers if I want, or I can make up letters. It's all the same. So if I was to make up letters, I'd call the length would be 5x, because I'll just go x, 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 x. So the length is 5x, which is no big deal. The width can be y. So therefore the area of the full rectangle is 5xy. Okay. Next thing we're going to do is I'm going to get the area of each individual part. So the area of rectangle 1, so I'm getting the area of all the shaded part. So rectangle 1 is length by area, which is x, y. Triangle 2 is a half base times height. Its height is y, but its base is 2x. So it's a half 2x multiplied by y, which is once again xy. So triangle 2 is also xy. Now triangle 3, however, is that little bit smaller. Triangle 3 is going to be, it's x in width, y in height, so it's going to be a half base times height, which is x times y. And then finally rectangle 4 is once again x times y. Going to add them all up together, and we get xy plus xy plus xy is 3xy. We get 3.5xy, or 3.5xy, or 7/2 xy. Divide that by the entire amount, which is 5xy. So 3.5xy divided by 5xy multiplied by 100, and you should get it 70% filled. Okay guys, so that should be 70% full. Okay, next one. Kerry has some ball bearings, and each one is shaped of a sphere of a radius 6 millimeters. Find the volume of one ball bearing. Well, it's the volume of a sphere, which is 4/3 pi r cubed. Keep it answer in terms of pi, so it's 4/3 multiplied by pi multiplied with 6 cubed. Just enter that into the calculator. What's it? 4/3, then you can press the pi button, shift pi, 6 cubed, 6 power 3, and you get 288 pi millimeters squared. Millimeters cubed, I mean, my fault. Now, Kerry's going to melt down some of her ball bearings. She will use this material to make a sphere of radius 25 millimeters. Find the least number of ball bearings Kerry must melt down so she has enough material to make the sphere of radius 25 millimeters. So I'm going to find out the volume of this new sphere in terms of pi. So volume of new sphere is going to be 4/3 pi r cubed, so it's going to be pi times 25 cubed. Okay, so we put in this in the calculator, 4/3 pi 25 cubed, and what we get here is 62,500 over 3 pi. Okay, once again millimeters squared. So what we need to do is we need to divide the volume of the large sphere divided by the volume of the small spheres to find out how many ball bearings we actually need. Okay, so what we're going to do is volume of a large sphere divided by volume of small sphere, or our original sphere, and what we can do is we can figure out how much we need there. So it's just going to be 62,500 pi over 3 divided by 288 pi. Put that into the calculator. So that's 62,500 over 3 pi divided by 288 pi. And there we go. It's 72.337, but you got to round that off to 73 because you can't have 0.3 of a ball bearing. So 72.33 or 73 ball bearings. Okay, good job. So that's question 3 done. Then we have part 3. Kerry has 350 ball bearings in total. Find the radius of the biggest sphere Kerry could make if she melted down all 350 ball bearings. So this means you're going to get 288 pi multiply by 350, and this tells us the entire amount of material we have. So 350 multiplied by 288 pi, and we get 100,800 pi. Okay. Next thing we're going to do is we're going to say that the volume of our new sphere, which is 5/3 pi r cubed, equals the volume of all 350 ball bearings, because that's how big this sphere is going to be. On both sides you can cancel off the pi. It's about getting the radius on its own. So how do you get the radius on its own? Well, division of 3 on the left would be multiplication of 3 on the right, like so. Multiplication of 4 on the left will be division of 4 on the right, and that leaves us the radius cubed. So it's going to be 3 times 100,080, I believe. It's 100,800 pi. Sorry, I forgot the pi there. My fault. Oh, and we cancelled the pi, my fault. Pi is gone. Yeah. So that would be 3 times 100,800 divided by 4, which is this number here, 75,600, is the radius cubed. Now, what number, when you multiply it by itself 3 times, gives you 75,600? So this means your R value will have to be the cube root of 75,600. So we press Shift, button, 75,600. And our answer will be 42 centimeters, or 42.2 to the nearest millimeter, 42 millimeters. So that's 42 millimeters right there. Okay, let's have a look at question 4. We have a stem and leaf diagram below, shows number of copies of New Renew sold each week over 17 weeks in a particular shop. The value diagram for one of the weeks is P, where P is element of N. So just basically means you sell P is a regular number, like P has to be bigger than 3, so it could be 5, could be 6, could be 7. Just has to be a natural number, is what they're basically saying there, okay? Now, what do they want from me? The range is 39. Well, that gives away P, because P, take away the lowest number, the P is the biggest number take away the lowest number is 39. This must mean P has to be 47, because it has to be 39 plus 8, which is 47. Okay, next part, find the mode. Well, the mode is the most common result. So which one's the most common? I see 3 19s, so I'm thinking 19 will be the most common result. Okay, next thing we're doing is the median. But please remember, the median is the middle person in this list. So how many people are there in this list? We know that P is now 47, so we change that there. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 people. What's 17 divided by 2 is 8.5. 8.5 must round off to the 9th person. Who is the 9th person in this list? 1, 2, 3, 4, 5, 6, 7, 8, 9. The 9th person is 21. I think there's 19 people. 17. Ah, yeah, it's 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16, 17. I'm just counting 17 people because there's 17 weeks there, so my answer would be different than the American scheme, but the American scheme, I believe, made a mistake. So the 9th person, which is 21. Okay, let's move on to the next part. The sum of the data in the stem and leaf diagram is 431. Use this fact to find the median of the data. Well, so what we're going to have here, guys, is we're going to have 431. 17 numbers add to give you 431. So the average of each number is 431 divided by 17, which is 25.35, which should be an average of 25.4 copies. Okay. Next part, D. In the 18th week, there was a special issue in the news, and there was a lot more copies sold than any other week. Find the modal number of copies sold per week over the whole 18 weeks, i.e. the mode. So look, guys, we're just going to make up a huge number at the end of this list, okay? So let's say 49. 49 was week 18, was 49, just for argument's sake. And that was more copies than they sold in any other week, okay? It's no big deal. So what's going to happen is the mode will stay the same because it has to be bigger than 47. So the mode remains unchanged. Okay, so still 19 copies. The median, however, has now changed because the median is no longer the middle of 17 numbers, it's the middle of 18 numbers. And 18 numbers is even. That means there'll be two results in the middle. Just like 4 people, the average, the median is the average of the middle 2. So we're going to have to divide 18 by 2 to get 9. And if it goes in perfectly even, which is the 9th, it means you need both of them. So we need the 9th and the 10th. So it's going to be 21 and 25 respectively. Got to get the average of the two of them. So we put in our work here, which is 18 divided by 2, which is 9th plus 10th, which is 21 plus 25 are the two numbers. You divide them by 2 and you get a median of 23. The mean number of copies sold that week, whole week, was 28.5. So we have a new mean. The mean went up. We did have a mean of 25.35. So we were on a total of 431 over 17 weeks. So what happened here was we had 17 weeks was 431. So 17 weeks was 431. We now know that 18 weeks has a total of 18 multiplied by 28.5. So what's 18 multiplied by 28.5 is 513. So week 18 must be the difference of the two of them. So it's 513 taken by 431, which is 82 copies. So this means we must have sold 82 copies on that last day to make the mean go up by that much. Okay. Next part. We are going to do question 5. A box contains red pens and blue pens. The probability that a pen is picked at random from the red box is 2 and 7. Write down 3 possible values for the number of red pens in the box. Alright, so if you imagine this, imagine a circle, okay, and you could have you have 2 out of 7. So 2 and then 1, 2, 3, 4, 5, right? But if I just double them, I could also have 4 and 10, and it's the same ratio. Or I could have 6 red pens and 15 blue pens, and that'd be the same ratio as well. So I can have any multiple of 2 I want. Okay, it doesn't have to be 5. It doesn't have to be 5 and 2. It could be 10 and 4. It could be 15 and 6. So I could have 2, 4, 6, any even number of pens. Now I find the probability that the pen picked at random was blue. Well, that's 5 and 7, no matter what way you look at it. Okay, nextly, explain why there cannot be exactly 20 pens in total in the box. Well, if you take that, it's 2 parts red, 5 parts blue, which is 7 parts total. 7 parts cannot equal 20 pens because 1 part, you can't have a decimal of a pen. Okay, or let's say 2 sevens of 20. Well, 2 sevens of 20 would be 5.7. How can you have 5.7 red pens? 7 parts does not go in equally to 20 pens, has to go in equally. Okay, some green pens were put into the box so that 25% of the pens in the box are now green. 1 pen is then picked at random from the box. Find the probability that the pen is blue. Give your answer in the simplest form. Okay, this is going to be interesting. Just going to start off with visual aids here. So I have 5 blues. I got 2 reds. Currently have a total of 7. I'm going to start adding in greens. That'll be 1 out of 8 are green. Well, I think I got look. No, 1 out of 8 is not right. 2 out of 9. Nope. 3 out of 10 are green. No, so this way I actually skipped it. I was at 12.5% green. I was then at roughly 22% green. Now I'm at 30% green. So that system ain't going to work. So I'm going to double the red and blue pens again. So I'm not going to start off with 10, 5 and 2. I'm going to start off with 10 and 4. 2, 3, 4, 5, 4 there. Okay. So currently I have 4 reds, 10 blues. So that's 14. So let's try this again. So this time when I add in 1 green pen, I'm on 14 pens to begin with. So when I add in an extra green pen, it's going to be 1 out of 15, which is no good. I add in another one, that's 2 out of 16, no good. Let's go again. 3 out of 17, no good. 4 out of 18, no good. 5 out of 19, no good. And 6 out of 20, no good. What is 6 out of 20 in a decimal or in a percentage? Yeah, I've already gone over 25%. Once again, I wasn't able to hit the 25% here either. So this time I'm going to start off with 15. I'm going to start off with 15 blues. Sorry guys, I'm going to start off with 15 blues. This is very much a trial and error question. 15 blues and 6 reds. Once again, that's still a ratio of, remember, 5 is to 2 or 2 sevens. So 15 reds, 15 blues, 6 reds, and now we're going to start adding in greens and see if we can make this question work out for me. Okay, so let's try this again. If I add in a blue, there's 21 of them already, so if I add in a green, sorry, it'll be 1 out of 22. If I add in a second green, it'll be 2 out of 23. If I add in a third green, it'll be 3 out of 24. If I add in a fourth green, it'll be 4 out of 25. If I add in a fifth green, it'll be 5 out of 26. I think we're going to get lucky here, guys. If I add in a sixth green, it'll be 6 out of 27. And finally, if I add in a seventh green, it'll be 7 out of 28, which is 1 in 4, which is the percentage we were looking for. Okay, so now we know there's 28 pens in total. Okay, so there's 28 pens, and out of those 28 pens, 15 of them are blue, so it's 15 out of 28. Okay, well that was fun. So that's a manual way of working it out. 6. You have Clara, she has some questions, okay? Clara asked the students whether some skills about eating and exercise. One of Clara's questions was, how healthy is your diet? Very healthy, fairly healthy, not very healthy, very unhealthy. To me, I find those words hard to tell which one's which, so it's not that accurate a question, to be honest. So what they found out is she drew out a pie chart to show her results. Her results and size of angles in the pie chart are shown by the table below. So what we have is 150 students equals 90 degrees. This means 1 degree would be 150 divided by 90, which is essentially 5 over 3, and that's 1 degree. 360 degrees is going to be 150 divided by 90, because that's what 1 degree equals, multiplied by 360. That means there were 600 students in total, because 360 degrees equals 600 students. Okay, so that's good news starting off. Now, what do we need to know next? We would first of all like to know what 96 degrees would be. So using this number here, using this in the red box, see the 1 degrees equals 150 over 90. Just going to multiply that by 96 to figure out what 96 degrees is. So multiply by 96. So 150 divided by 90. Multiply by 96. We get 160 students for that one. Okay. Next thing we're going to do is we're going to do the reverse situation, where we found out that 1 degree was, we know that 150 people equals 90 degrees. So let's find out what one person is. Well, one person would be 90 divided by 150. So 170 people would be 90 over 150 multiplied by 170. So this to find out how much angle it's worth. 90 divided by 150 multiplied by 170. 102. This would be 102 degrees right here. Okay. Now we know there's 600 students in total, so we just get 600. Take away 160. Take away 150. And take away 170. And what we should get there is 120 students odd. So there we go, 120 students odd. Regards the angle, if we get 360, and we take it away from 360, take away 96, take away 90, take away 102, and we should get a 72 degrees. Okay, I think the next thing we're going to have to do is draw this Venn diagram. Okay, so what we're going to do is we're going to copy and paste these numbers here because we're going to need them. Make it a bit smaller. Okay, so now to actually answer this question, right? From the probability that a student chosen at random from those surveys tick the very healthy or fairly healthy section. So add up very healthy and fairly healthy. So that's those two results combined. And that will be I suppose you could do it this way, 96 plus 90, which is 186. Sorry, all these workings in the wrong spot. So it's 186 divided by 360, which is a ratio of 31 out of 60. You could have also done 160 plus 150, which is 310, divided by your 600, which is also 31 out of 60. Either method would have done nicely, okay? Now, B, complete the table above. Done. Doesn't actually ask me to draw the pie chart. C, complete the table below showing one question in each that Clara could ask that would generate this type of data. Okay. So, we're looking for a numerical continuous, okay? So this means it has to be measured. So you could say, what volume of water do you drink every day? This is a continuous answer because you have to measure the amount of liquids. If it's a measurement, I can never say I drank exactly 500 milliliters. It'll either be 500 milliliters and a tiny little bit or 499.999 milliliters, okay? Numerical discrete means it's either is or isn't, okay? So what you say is, how many press-ups can you do in 30 seconds? Will be a good way of saying it. Because you either do one press up, half press ups don't count. Okay, any question that will generate a numerical answer that is or isn't has to be 1 or 2, 3 or 4. There is no 3.5 or anything like that. Okay, next one, categorical. We need to get a categorical answer. Okay, you can just say, what is your favorite food? You say what your favorite food is. There is no order in the answer. Everybody has a different favorite food, okay? So there's no order to the answer, okay? So that's all right. Clara is worried that students in her school are not a representative sample of all the students learned. Why is it important to have a representative sample when doing statistical research? Okay, so maybe the people in Clara's school might be really healthy. So you can say just so the results aren't biased. Or so that the results will apply to the whole population. Means it'll apply to every school in the country, not just our school, okay? And not just a sample. Okay, happy days. Now, what's next? I think that's us done with that now. So guys, that's question 6D done, and that will be me for today. It's a good 38 minutes.